Next we shall have a look at what is Maxnet. Next we shall have a look at what is Maxnet. Maxnet is a recurrent one-layer network that conducts a competition to determine which node has the highest input value. So you can see one Maxnet which is shown here. There are 5 nodes and all these 5 nodes are in one particular layer. And what happens is that this is a sub-network. It is a sub-network with n nodes which are completely interconnected to one another. So if at all there are 5 nodes, you can see that there will be 5 weights which are going from one node to all the other nodes. So if at all you consider this particular node, from this node there is a weight going to itself, there is a weight going to the other node, this node, this node and this node. So there are weights which will be connecting that node to every other node. So it is a completely connected network. Now it is a recurrent one layer network. Why it is recurrent? So whatever is the value at this particular node, the output of this node will be fed back to itself, and whatever whatever is the value of this node, with this weight it will be given to this node, this other node. So basically it is a recurrent network because it is only one layer, and again whatever is the output is fed back to the input. So there is only one layer and it is a recurrent network, such that if at all I draw it in the other way around, that there are 5 nodes, I can say that, say this is one node and this is the other node. So what happens is that whatever is the output which is generated is given back at the input, and whatever is the output generated is given to the other node also, and whatever is the output which is generated by this one is given to this particular node also. So basically every node is connected to every other node by feedback paths, and that is the reason we get a network which is shown in this diagram like this. So it is a sub network. So when I say it is a sub network, it will be getting its input from some other network, and it is only a part of a network, or it is a layer of a network, and that layer of a network is called as Maxnet. Now what is the conclusion of this? There will be a competition which will be held among these nodes, and finally one of the nodes will emerge as the winner node. That is, only that node will produce a maximum output, and rest of all the nodes have to produce a zero output. So which node will be the winner node is the one which had the highest initial input value. So the first time, whenever what is the first initial value, if whichever one has got the maximum value, finally that node only will survive. So it is like a person who gets very good marks, say 25 out of 25 in IT1. What happens is that we have to ensure that the same person becomes a topper in the semester exam. So whatever happens, IT2, IT3, IT, whatever ITs and semester, we have to ensure that the same person becomes the winner. So whoever was the winner earlier, the same has to be the winner throughout. So that is what will be happening in a Maxnet. So every node in a Maxnet receives inhibitory inputs from all other nodes via lateral intra-layer connections. So these are inhibitory inputs. Now what is the meaning of inhibitory inputs? Supposing in a class there are, say, 5 toppers, or 5 students who are competing to become the toppers. Now what will happen is that initially, say, obviously everybody's marks will not be the same. Okay, some person will have good marks than the other person, and so on and so forth. But 5 of these people are competing to become the winner, that is the topper. Now what will happen is that there will be some inhibitory connections between them. What does it mean? This one doesn't want this fellow to become the topper. Similarly, this one doesn't want this fellow to become the topper. So there is some inhibitory connections that is within the layer, that is intra-layer connections are there. But everybody wants to become the topper. So whatever is the self weight given to itself will be positive, that is excitatory weights, and the weights which are given to the others will be negative weights, meaning it is like if at all you do not want somebody else to become the topper, then you will be telling them some questions to study which may not be appearing in the exam or something like that. You will try to, if you feel something is important, you will not tell the other person, so you will be giving inhibitory excitations to the other nodes. So because finally they are competing with one another, so to each other they are giving negative weights, that is inhibitory inputs, and to itself they will be giving excitatory weights, that is it is called as the self excitation weights. Now the self-excitation weights theta are approximately equal to 1, and the mutual inhibition weights which are there, they are all equal weights, and it is less than or equal to 1 by n. So if at all there are say 5 nodes, then it will be less than or equal to 1 by 5, or it is mostly can be kept as equal to 1 by 5, but remember it is going to be negative weights. Now such weights are chosen such that the single node whose initially the output value was maximum, that can prevail as the only active or the winner node. So supposing, say this particular node I take, it had a maximum value initially. Say supposing this one had say zero point 0.9, this one said 0 0.8, 0 0.6, 0 0.5, 0.2. So which is maximum? This one is maximum. So finally what has to be done is that it should be such that all these others will be becoming 0 and only this one will be having some output. So that is what will be the final result of the maxnet, that is whichever was initially the winner node, that particular node has to be declared as a winner, that should produce the output, and the rest of the other nodes should produce 0 output. Now, in order to do this, the activation function which will be used is ReLU function. So, every node will be using rectified linear unit function. So, the output, if at all the net which is calculated at every node, that will be, you will be taking maximum of 0 comma net. So, if at all it is net is negative, then the answer will be 0. If at all net is positive, then the answer will be net itself. Now Maxnet is used as an upper subnet for a Hamming network. Now what we have seen in a Hamming network is that a Hamming network will determine the Hamming distance, and indicating which of the stored pattern vector the input vector is closest to. So it will be closest to any one of the pattern vectors. So that particular output has to be maximized and the rest of the outputs have to become 0. So what happens is that the output of a Hamming network can be given as the input to the maxnet, and that is when it will be a combination of both of these network will be called as the minimum HD classifier, that is minimum Hamming distance classifier, which is made up of Hamming network and a maxnet. So maxnet is a subnet, it cannot be used on its own, but there should be some other network which is feeding the output, feeding its output to the maxnet as its input, and then those there will be some iterations which will be taking place in such a way that only the maximum output which was there initially, that will remain, and the rest of the outputs will diminish to 0. So the outputs of the Hamming net are connected to the maxnet, which calculates the best exemplar match to the input vector. This I have already told you. So now we shall be solving a problem on maxnet, and although I have not drawn the weight matrix here, you can draw the weight matrix from the problem. Okay, so while doing the problem you will come to know what is the weight matrix.